All right, we're now going to do predicting products. So it's only going to tell you what's on the left side of the equation, and you have to predict what's on the right, but it still works that same way. We start off left to right, just like you read, and we transcribe the words into equations. Strontium powder. SR is strontium symbol. Powder means it's a solid. Reacts with hydronitric acid. So plus hydronitric acid. Okay, that means I know it's binary because it started with hydro and ended with ic. Nitra means it's a nitrogen base. Okay, so I just need to react the cation of hydrogen with the anion of nitrogen. I need to crisscross. Acid means aqueous. And then there's my reaction arrow. So here's where then I have to use that information of what's going on. I have a single and a couple. Anytime I have a single and a couple, it's a single replacement. Strontium is going to kick out hydrogen because strontium is a cation. Hydrogen is a cation. You can only can kick out like. So a cation can't kick out an anion. Okay, and this also shows me that strontium is stronger than hydrogen. That's our driving force there. That's what's making sure the reaction is going to happen. You don't have to know why strontium is greater than hydrogen for first year. So if strontium's kicking out a hydrogen, that means strontium's now going to be bonded with nitrogen. SR, and strontium's in group 2, so it's a +2. Nitrogen is a -3, so we crisscross. And we'll come back to its solid, or its state symbol. And then who's going to be left by himself? Well, hydrogen was kicked out, so that means hydrogen's now going to be by himself. But hydrogen needs to have his twin when it's by himself because he gets scared when he's alone, because hydrogen's diatomic, Brinkelhoff. And H2 is typically a gas, so you're going to infer that it's a gas there. You are predicting what these state symbols are. Okay. And strontium nitride, we started out with an aqueous solution, so we are going to end up with an aqueous solution because nitrides are soluble in water. Okay. And then we rewrite it, strontium solid plus hydronitric acid, aqueous, yields strontium nitride, aqueous, plus hydrogen gas. And I left those lines in there because the equation does not count unless it's balanced. Okay, I have SR, H's, and N's. 1 SR, 3 H, 1 N. On the other side, 3 SRs, 2 N's, 2 hydrogens. Okay, I see I have an even odds situation here. So I'm going to use the least common multiple, which is 3 times 2 equals 6. So I want to make it so I have 6 hydrogens on both sides. 3 times 2 is 6. Or over here, 2 times 3 is 6. So now I have 6 hydrogens on the right. And I have 6 hydrogens on the left, but don't forget that means I also changed my nitrogens. I now have 2 nitrogens, which I'm in luck, that actually balanced my nitrogens. So the only thing that's left over to do is balance my strontiums. Conservation of mass is met. My equation is balanced and I am done.